welcome back to my YouTube channel. Long time no see. Okay, without any delay, let's get started straight away, okay? So I'm doing Form 5, Chapter 2, Differentiation today because based on what I know, if you already learned in school, this chapter is always one of the problem of majority of my students because this chapter is very big and then every single subpart is totally not related. So that's the reason I decided to do this chapter for majority of my Form 5 students. And today's video, I only will cover the very basic thing of how to differentiate. So how to differentiate is super duper important for this whole chapter because just imagine you don't know how to differentiate. You couldn't even survive every single subpart in this chapter because everything in this chapter required differentiate. Okay, that's why this chapter called differentiation. So that's the reason you guys must know how to differentiate, okay? So without any delay, let's straight away do it. So guys, differentiation is actually just a step to do it. I won't tell you what is the meaning of differentiation. We just purely learn how to differentiate, okay? So differentiate actually only got two steps. The first step is times. The second step is -1. Maybe I say like that, you don't understand anything. Never mind. Let me give you some example. Let's say y equals to 5x cubed. Okay, guys, look, the moment they want you guys to differentiate this, you will always write a name after you differentiate, okay? You won't just straight away differentiate. You will write dy dx. Why will you write dy dx? Okay, guys, look, listen. D stands for differentiate. So now you differentiate y. Inside is in terms of x. That's why we will call it dy dx. That means, what if they say s equals to 5t cubed? When you differentiate it, will you call it dy dx? No, you call it ds dt because outside is s, inside is t. What if they say a equals to 5r cubed? Same thing. When you differentiate this, you guys will call it dA dr. Cannot, my dear. Now you guys get an idea of how to form the name. I hope you did. So isn't it just like that? So let's get started. How do we differentiate that? So based on what I told you is times and -1. Then how do we times, how do we -1? Okay, please bear in mind. Every time you guys want to differentiate, right, the very important thing is the unknown. So now y equals to 5x cubed. The unknown is x because we want to differentiate in terms of x, correct? So what you will do, you will always look at the unknown's power and you will start from times and -1. So it means that you will times, you see, 3, 5, 15, correct? You will use the unknown's power, you times. After the power times, then you will -1. Who -1? Everything is happened for the power. So after you times, next, you guys will take the power and you tolak 1. So 3 -1, isn't it 2? And what else? Nothing else. Just like that. Done. This is how you differentiate. So I repeat, you look at the unknown power, you times, and then you -1. Not too sure? Never mind. Let me give you the next example. Let's say this one. Okay? So again, they want me to differentiate. Outside is y, inside is x. So that's why we call it dy dx. How do we do it? Every time we differentiate, we will look at the x. So we will times and then we -1, okay? So 2 times 4, 2, 4, 8. After we times, and then based on what I say, you will -1. So 2, if we -1, isn't it 1? Got it? Got it. Obviously, the 1 is not necessary to write, okay? But I still write for you guys just in case, I don't know, just in case you don't know why there's nothing there. So it's actually a 1, okay? So y equals to 3x or something different now, okay? So guys, again, you want to differentiate it. Outside y, inside x, dy dx. How do we differentiate this? A lot of students, maybe they were confused when you see something like that. So whenever you want to differentiate, you will look at the x, the unknowns, right? So you will base on the unknown's power. But this x, I don't see any power there. So if I don't see any power there, you think, what is the power for this x then? Very good. I expect all of you very good because you guys Form 5 already, right? So very good. It will be power 1. Because just imagine it. If you don't see it, impossible power 0. Power 0, I won't even see the x. If I can still see the x, isn't it the power should be invisible 1? Because usually 1 we don't write, right? So again, the working is the same. We just times and -1. So 1 times 3, 3, correct? After that, our power, we will -1. So 1, if we -1, eventually is 0. So 0, that means I don't have x anymore. So if I don't have x anymore, do you think I'll write x power 0? I don't think so. X power 0, you already learned under indices. Anything power 0 will be 1. So it's not necessary to write, but I can still write for you. So 3. So x power 0 is actually 1. So isn't it the final answer is just a 3? But obviously, no need to write so many steps. On the starting, you can straight away write 3. You can just ignore the x power 0 and no need to write that. You also get the answer 3 straight away. I hope you are fine. If I'm way too fast, you can just pause and digest, okay? But I think I'm way too slow for majority of the people. You guys can try to speed up, okay? YouTube, the best thing about YouTube is you guys can manipulate my speed, okay? So next one, what if they say y equals to, let's say 8. How do we differentiate this, my dear? Okay, so look, again, differentiate it, we will call it dy dx, correct? How do we differentiate this one? You must be thinking, oh, teacher, this one very hard. This one don't have x. Because based on whatever we did just now, we will always depend on the x for us to times and minus 1. This 8, I don't want to differentiate now. I don't even see any x. So if I don't have any x, let's say, okay, I force myself to write an x there, okay, to make you guys understand. So if I don't have x there, isn't it, if I force myself to write an x there, it means they will have 0 x there. Because I don't see any, then obviously no x. No x, that means 0 x, correct? You cannot suddenly add a power 1 now, my dear, because you don't have x there, right? So it's power 0. So again, now we can do the same thing of times and minus 1. So you see, 0 times anything is literally 0. And then power minus 1, isn't it x power negative 1? But do you think is it necessary to write the x power negative 1? No. Because 0 times anything, isn't it 0? Done. Can you see it? Actually, after this 4, I hope you guys realize one thing, that every time when you differentiate something with x, you will definitely get some answer. Okay, you will get something after you differentiate. But if you differentiate something without a x, you will straight away get 0. Can you see that? Because no x is always x power 0, and 0 times anything is always 0. That's why no x differentiate is always a 0. Never mind, I will do more, okay, if you don't get it. Next one, let's come out something different. Let's say 1 over 2x squared. How do we differentiate this? Don't because they suddenly have a fraction, you feel like very panicked. The way of doing it is exactly the same. The moment we differentiate it, we will call it dy dx. Correct? That's the name of it, right? So with times and minus 1, okay, the step just never changed, man. So my dear, we times. So 2 times 1 over 2, you guys can press calculator if you don't know. So when we times fraction, we always times the top. 2 times 1 is 2. Bottom, it is of course still 2. Then after that, we will minus 1. 2 minus 1, isn't it 1? So 2 divided by 2 is 1 again. Isn't it the dy dx answer is x? Saw it? One more. Y equals to negative x cubed over 7. Again, how do we do this? The way of doing it is exactly the same. The moment you differentiate it, we will call it dy dx. So I repeat, you will just times and then minus 1. So this time, how do I times? I saw the x here, correct? I should times something in front, but in front, I don't see anything. If I don't see anything, will you write a 2 there? Will you write a 3 there? No, you guys cannot change the original questions, right? If there's nothing there, impossible 0. 0 times x cubed, you won't even see the x cubed. If you guys still can see the x cubed, isn't it in front will be invisible 1 there? So again, we times and minus 1, yeah? So 3 times negative 1, isn't it negative 3? And then power minus 1. Power, if I minus 1, isn't it become power 2? Bottom, it is still a 7. Ta-da! That. Understand all, guys? I just times and minus 1 throughout the whole example. I hope you guys all understand so far. Is it okay? Okay, I think can, okay? Next one. I'm very panicked. Okay, guys. Next one. Give you another example. Let me think about it. Okay. Look carefully, 2 over x cubed. This time, something different, How do we differentiate this one? Do you guys realize, based on all the first row example I gave you, always you want to differentiate, you will very depend on the unknown, which is obviously the x now, right? And then do you realize just now when you differentiate it, all your x is on top. Can you see it? All of it is on top, correct? Now, problems happen that your x at the bottom. So some student, you will straight away differentiate it, but let me teach you the nature of how do you guys do it. Remember, when you want to differentiate, you will always look at the unknown, and the unknown shouldn't be at the bottom. They should be on top. So if they're at the bottom, what can you do? You guys can actually bring it to the top. When you guys learn this before, you guys learn under indices basic. Isn't it fraction? When they're at the bottom, you're allowed to bring it on top as long as you guys make the power. Hope you answer me correctly. Negative, my dear. Basic, right? So same for this one. If I want to differentiate it, I just need to bring it up. So if I bring it up, right, the x, I will just put a negative. You know, some students, when they just bring the power up, right, they will write dy dx. I totally don't get it. You haven't started differentiate, you know. You just bring the x up to change another way of writing it. So that's why they are not dy dx, they are still y. Because you just bring it up, you haven't started differentiate, okay? The moment you start differentiate, only you guys will write dy dx. Understand? So how do we differentiate, guys? We will times and then we will minus 1, okay? Like what we did just now. So we times negative 3 times 2, isn't it negative 6? After that, we will minus 1. Negative 3 minus 1, isn't it negative 4? So I think my example is exactly understandable because it's the same thing as the previous one, right? So you just need to times and minus 1. I know a lot of students will stop here. Obviously, your school teacher don't mind as well. But my suggestion is, because this chapter at the back of it, they will have like a very, very complicated stuff happens at the back. So you better always have this good habit to write your answer in the most simplest form and the most nicest form also. So that's why I won't stop here. I will try my best to make the power negative disappear. How do I make the power negative disappear? Because do you remember how do you guys have a power negative? Is because just now they at the bottom, you bring up, that's why I got power negative. So if one day you don't like the power negative, you just kick them back down. So if I don't like the power negative, I will just bring it down. Some students, they will tell me, teacher, will you bring the 6 down? No, because this power is only for the x. So please understand that the 6 will still stay on top. You will only bring the x down. That's why the power will become positive now. That is the answer. Do you think you understand? Don't understand also, never mind. I can give you more example. Let's say negative 1 over negative 8 over x power 3. Is it a good one? Okay, doesn't matter now. Okay. No. X. Negative 8 over x. This is a good example, my dear. So again, how do we differentiate this? I repeat, whenever you want to differentiate, please make sure your x is on top. Now my x at the bottom. What can I do again? Bring it to the top. So how you guys bring it to the top based on what I just taught you? When you bring it to the top, they are still y. You haven't started differentiate, okay? So when you bring it to the top, guys, the x will power put a negative. But the problem is, this x, do you see any power there? No. No power, I think they are power 1. Correct, right, my dear? Nothing there is actually 1, invisible 1, based on what I'll show you. So if you bring it up, then power now, negative 1. Okay? Then only you guys start to differentiate because now it's ready. My x is on top. The moment I start differentiate, I call it dy dx. So again, we're going to times and then minus 1. Negative 1 times negative 8, positive 8. Then the power, if we tolak 1, negative 1 minus 1, negative 2. Again, that please have this good habit. Don't stop here. Try your best to make the power negative disappear. How? Bring the x back down. They will become power positive. The 8, remember, still stay on top because the power only for the x. Do you get a very good idea of how do we do differentiation? Let me give you another example. Y equals to 3 over 5x power 5. This one, how do we do it again? So guys, the concept is exactly the same. So every time you guys want to differentiate, please make sure your x is on top, not at the bottom. So this x at the bottom, what will I do? Bring it up, correct? You know, some students, they make mistake is because they thought that they need to bring the whole thing up. You look carefully my example on the previous part. Do you guys realize just now when we differentiate these two, right? The number at the bottom, do I ever bring the number up? No. The number at the bottom, do I ever bring the number up? No. This tells us that number is never a problem when you differentiate. You just need to make sure your unknowns is on top, not the number. So for this one, so please, no need to bring the 5 up. Just bring the unknown. So the unknown you bring up, power put a negative. Can you guys see that? So don't tell me, teacher, why can I, and you guys will ask me, teacher, can I only bring the x up? Obviously you can. You know why you can, right? Because this 5 and this x, nothing in between is a times relation. So when I bring it up, are they still a times relation? Yes, they still are times relation. That's the reason it's all right for me to just bring the x up without bringing the 5, because I didn't change the nature of the questions, okay? So like that, they are still y because I haven't started. The moment I start differentiate, only we call it dy dx, correct? So how do we differentiate it? Now we will times and then minus 1 again. So guys, times are negative 5 times 3 is negative 15. Then the bottom still the same. Obviously, you guys can straight away write negative 3, okay? I just scared, some of you guys don't know. So I just want to cover all for like those very basic, not very good students, okay? So power, if I minus 1, negative 5 minus 1, isn't it negative 6? Saw it? So negative 15 divided by 5, negative 3. And then this one still here. Will I stop here? Nope, because the negative I don't like. I will kick them back down to make it power positive. That easy. Give you one more example, okay? May I? Negative 1 over 4x squared. Can lah? So guys, again, how do we differentiate? I repeat the same thing again and again. Every time you differentiate, please make sure your x is on top. So if my x at the bottom, I will bring it up. No need to bring the 4 up because number never affected when you want to differentiate it. The moment you want to start to differentiate, only you guys write dy dx. Can? So we will just times and then minus 1. So negative 2 times negative 1 over 4. Negative, negative, positive. 1 times 2 is 2. The 4, it is still 4. Correct? The power, if we thought out 1, isn't it negative 3? Can simplify. Do you guys get 1 over 2 x power negative 3? Please don't stop here. Remember, make the power negative disappear by bringing them back down. That totally understand, right? I think you guys get an idea of how to differentiate. Let's try to do like one example. So question 1, differentiate each of the following function with respect to x, because they want to do in terms of x. Let's start from A. So don't, because now they are slightly longer, you tell me you don't know how to do it. Definitely you know. The way of doing it is the same, okay? So guys, again, how do we do this one? I repeat, every time you guys want to differentiate, please make sure the x is on top. So is my x all on top? Yes. Then I think this question very easy. I can straight away start differentiate and we will call it dy dx. So the moment we differentiate, we will times and then we minus 1. Correct? That's what we did, right? So the x is here. I repeat, nothing in front, it will be a 1, invisible 1. So we will times and minus 1. So 2 times 1, isn't it 2? Then the power, if we minus 1, 2 minus 1, isn't it power 1? It's not necessary to write the 1, but I just write for you guys, okay? Plus, how about the back one? Don't tell me, teacher, can I copy back? Impossible. Every time you differentiate, they will change to something else. So please do the proper step, okay? And don't tell me it's 0 because they have x definitely come out will have some number. So this 6x, nothing there is power 1. So 1 times 6, and then later on minus 1. 1 times 6, 6. Power minus 1, isn't it x power 0? Power 0, is it necessary to write? No. So isn't it the answer is just 2x plus 6. That can B. B, they say y equals to 3x minus 2 over x. Allow me to change the question a bit, guys. I want to put a plus 1 at the back. Okay? So again, how do we do this one? The way of doing it is the same. I repeat, no matter how long it is, the way of doing differentiation is totally the same. Please make sure your x is on top. So now when I look at it, I don't want to start differentiate straight away because I realize my x at the bottom. What I do? I need to bring it up. Correct? So guys, when I bring it up, some students are very funny one. They will tell me, teacher, can I differentiate this one first? My dear, you don't make your life so hard. You should make sure when you differentiate, you better differentiate it one go. Not this one differentiate first, this one later. Then this one differentiate first, this one later, then how do you guys call it? Then what if you confuse later, correct? So please make sure everyone can differentiate, that only we do it in one whole row, okay? So if I am you, I will still call it y. because I realized this one ready to differentiate, this one ready to differentiate, but this one not ready. So the first and the third will wait for the second one, okay? So how do we do it? So same thing, this one I just copy down. Why I copy? Because I need to wait for the second one. And the second one, nothing there is power 1. 1 when you bring up, isn't it power -1? The plus 1, isn't it still plus 1? Do you guys realize after the second one, the unknown, the x, I bring it up, isn't it now one whole row? Now one whole row, all the x is on top. Since all the x on top, I think they are all ready to differentiate. So let's get started. When we differentiate it out, we will call it dy dx. So how do we differentiate? We will times and then we will minus 1 like how we always do. So this x, nothing there is power 1. So 1 times 3, 3. Power -1. Do I still have any x left? No, 0. 0, no need to write. Then next one. -1 times -2. Negative, negative, positive. 1, 2, 2. After that, my power, I minus 1. -1, if I minus 1 again, isn't it power -2? So I just do whatever I taught you. Times -1, times -1. How about this plus 1? Not sure whether you answer me correctly, but I hope you did. So my dear, the 1 differentiate, I repeat, if there's no x there, if I force myself to write x there, I'll write x power 0 because I don't see x there. So it's x power 0, right? And then all of you know, you will times and minus 1, correct? 0 times anything will literally be a 0. So isn't it, they were just 0. I write for you, okay? Even though no need to write 0, but I scared you guys don't know. So it's a 0. So 0 unnecessary to write. So what is my final answer? Don't stop here. Remember, make your power negative disappear by bringing them back down. Remember, don't bring the 2 down because the 2 don't have power negative. So only the x got power negative. Just bring the x down and ta-da! This is the answer. Can? I think can. Let's go on C. C, they give me this one. The moment I look at C, not I don't want to straight away differentiate. I couldn't because they have like bracket and stuff like that, right? So of course, the first thing first is you guys should simplify it to make it easier. That only can start differentiating. So when I look at it, it's not very hard to do it. Isn't it? I can expand the bracket. So isn't it x times 2x, I will get 2x squared. X times 1, I will get 1x. -2 times 2x, I will get -4x. -2 times 1, I will get -2. Then those I can combine, I will combine like this one and this one. 1x minus 4x, isn't it? I will get -3x minus 2. Okay, somehow I already got this after I expand it. So after I expand it, then now I think it's quite ready for me to differentiate because all of the x is all on top. So the moment we start to differentiate, we will call it dy dx, okay? Again, now what we're going to do, we're going to times and minus 1. So guys, let's get started. 2, 4. Power, if I minus 1, isn't it become power 1? 1 no need to write. I just want to write for you, okay? Then this one also same. Nothing there is power 1. So we times and minus 1. So 1 times -3 is -3. Then the power minus 1, isn't it x power 0? Is it necessary to write x power 0? No, because no x. That means no x. So no x no need to write at all. And -2 differentiate will be, I hope you guys all say 0. I repeat again, why 0? Because this -2, I don't see any x. If I force myself to write an x there, isn't it you guys can write x power 0? So we will times and minus 1. 0 times anything will always be a 0. Unnecessary to write. Isn't it just like that? I got the answer. 4x minus 3. Done. D. Can or huh? Okay lah. I think can lah. Okay. I very lack of confidence because I couldn't, hear a response and stuff like that. I'm like talking to myself, but yeah, hopefully can. Hopefully this speed is perfectly fine, okay? Or maybe too slow, okay? Hopefully it's not too fast. So guys, D. D, they give me this one. So again, how do I do it? Again, I want to differentiate. Please make sure all your x is on top. So where is your x now? At the bottom. So you guys can bring it to the top, correct? So guys, when you bring it to the top, you will put power -2. So obviously you guys will get the answer, okay? But okay, you guys can do that method. I just like my own method, okay? Because I feel like this one is more basic, okay, because you guys learn it in primary school. So you guys can bring it up and then open bracket and start to differentiate, or you can do this. Because now I realize the fraction, the denominator is alone and don't have plus minus. When my denominator is alone, I think I have another choice, which is what? Isn't it when my denominator don't have plus minus, I can actually split it. Because please understand that the denominator is always for each and everyone on top. So isn't it I can split it? I feel like after I split it, it's easier for you guys to see it because they will be individual now. Can you see it? So after I split it out, now I can cut. I got 4x on top, you got 2x at the bottom, I cut. Isn't it? I will have x squared on top. How about the right-hand side? The right-hand side also the same. The bottom is an x. If I bring it up, isn't it power -2? I think you guys understand. Cannot I bring it up, it will be power -2. So I just need to make sure all my x is on top before I start to differentiate it. That's why they are still a y. And the moment you start to differentiate, only we will call it dy dx. Correct? Again, let's do it. Times and -1. Nothing in front, 1. So 2 times 1, 2. Then power -1, isn't it left 1 of it? Okay. Next one. -2 times 1, -2. Saw it? Then power -1, isn't it become -3? So the whole journey, I just times and -1, times and -1. Can you see I never changed the way of me doing it? I hope by now you guys totally get it. And please remember, have this good, very, very, very good habit to make it the simplest form without writing power negative. How do we make the power negative disappear? We just kick them back down. And remember the 2 stay on top because the power only for the unknowns. Done. So far so good. Can I teach you another one? Let's go on with question 2. Okay, this question 2 slightly different now. Now I teach you, okay? Differentiate each of the following function with respect to x. Okay, guys, let's get started from A. Y equals to 2x plus 1 square. How do we do this? I repeat, based on what I taught you previously, you will always try to make it the simplest form so that you guys only start to differentiate, correct? And this one, I think quite easy because they are power 2, right? So power 2, isn't it? We can expand it. For those who forget what you learned in Form 3, because you already learned a Form 3 method called shortcut method. So for those who don't know, you guys can open this bracket to 2 and slowly expand it. You guys will get the answer. But I expect you guys can do shortcut method. So I do shortcut method, yeah? So always shortcut method, when you expand this, there's always 3 things come out. You will square the front, put it in front. 2, 2, 4. X squared. You will square the back, put it at the back. 1, if you square it, 1, 1 is 1. Okay? The shortcut method, always 3 things come out. So now you guys get the first one, get the third one. Then the middle is always using 2. Never change number 1. 2 times the 2 thing in the bracket. The first thing in the bracket is 2x. The second thing in the bracket is a positive 1. So 2 times 2x is 4x. 4x times 1 is 4x. This shortcut method, actually, you already learned in Form 3. If you don't know, never mind, you try to learn. Or you open 2 brackets also can. It's just a bit slow, okay? No matter what, you guys will definitely get this, okay? Once you guys get this, isn't this like the most perfect, simplest form? After you guys get the simplest form, I think now I can start to differentiate it as usual because I already see all my x on top. So let's again do it times and -1, okay? So guys, 2 times 4, 8. Power -1, 1. Okay, I stopped writing like the times and -1 anymore. So this one, nothing up there is power 1. Correct? So 1, 4, 4. Power -1, no more x left. Correct? Then how about the 1? The 1 differentiate will be 0. Very good. I repeat again, just in case you know you have short-term memory. Even I just taught you 5 minutes ago. So the 1 don't have x, isn't it? X power 0. And all of you know, 0 times anything is 0. Ta-da! Isn't it? I got the answer 8x plus 4. Correct? Now, I want to teach you guys another method to differentiate this same particular thing. Why I need to teach you another method? Because you must understand. Just now, the first method I show you, okay, is because you can expand it, because now they power 2. Just imagine if this is not power 2, this one power 5, 7, 10, 1000, my dear. That kind of value, can you expand the bracket? No. So now I want to teach you guys how to differentiate if they got a bracket. Okay, so it's actually a formula also, but instead of a formula, I straight away teach you. Okay, I think understanding is better and easier than memorize a formula. So how do we do this one? So this time I decided not to expand it. Okay, instead of expand it, I straight away differentiate it. Then how do I differentiate if there's a bracket on? Okay, my dear, let me tell you, just now, based on what I told you the whole day, isn't it when we differentiate, we will just keep doing a times and minus one, this action, right? So do you guys realize when we do times and minus one, okay, we always look at the unknown x. So based on the x power, we times and then we minus one. We times and then we minus one, correct? Now, we don't look at x because now we start with a bracket. So instead of look at the x, we times and minus one, we will look at the bracket and we do the same thing. We also times and minus one. So it means what? Let me show you straight away, okay? So first thing first, I look at the bracket, right? Then I will look at the bracket power. I will continue. What color leh? Okay lah, red lah. We will times and minus one. We will do as usual, you know, but nothing in front, it will be a 1. Correct? So show you, 2 times 1, isn't it a 2? The bracket obviously still there. Then the 2, if we minus 1, isn't it power 1? Do you realize it's same thing like what we did usually? It's just normally it's the x, we times and minus 1. Now it's the bracket, we also times and minus 1, correct? So already done, times and minus 1. The way it never changed. Saw it? Then inside the bracket, what will I write? Inside the bracket, I will copy back whatever previously inside the bracket. Okay? Am I done? No. Why no? Do you guys realize when you do like that, right? Yeah, you done differentiate, you did the times and minus 1 thing, but when you times and when you minus 1, you only times and minus 1 the bracket part. The bracket inside part, that means you only do the external part. You never do the internal part. That's why whenever they got bracket, please bear in mind, whenever they got bracket, you must purposely add a small little bracket at the back. Why? This small bracket is actually for you to differentiate inside and put it at the back. So it means that you need to purposely differentiate 2x plus 1. So let me show you. 2x plus 1, if you differentiate it, what will we get? 1 times 2, 2. Power minus 1, no more x. And number differentiate is always 0. By now, you guys already know. Isn't it? That means I will get a single 2 if I purposely differentiate the internal part. Let me continue to show you. 2, 2, 4. The bracket still here. I continue to expand since there's no power. 4 times 2, 8. 4 times 1, 4. Now, guys, you know why I show you these two methods? Because I want to prove to you. You using my original method, you get 8x plus 4. You using my bracket method, you also get 8x plus 4. That means this method correct or not? Correct. So I hope you guys understand, no matter which method, you will definitely get the same answer. That. Understand better now? Okay, maybe no. Never mind. I can give you a lot of example. Let's look at B. So B, first thing first, when I look at this, some student, if their basic is not very good, first thing they will tell me, open the bracket. Please, you couldn't open the bracket because remember what you learned in lower form? Power always comes first. You must settle the power first. So don't tell me you times inside, okay? You should do the power first. Then power is 5. Can we expand power 5? No. Power 2 can, but power 3 onwards, we don't do that. So not I don't want to expand, I couldn't. So I think first method doesn't work because I cannot, try to expand it. So I must go to the second method, which is the bracket method, right? So let's try again. So now I got bracket. So how do I differentiate it? Differentiate it, we call it dy dx, correct? The way of doing it is still the same, which is times and minus 1. So let's start from the power, we will times. 5, 3, 15. Saw it with times. After that, we will minus 1. 5 minus 1, isn't it 4? Saw it? So with times, we minus 1. Inside the bracket, we will just copy back whatever they previously write. Will I stop here? No. Please remember that you must add a small little bracket at the back. Because if you times and minus 1, you only do the external part, the inside part you copy it, you never do it there, right? So you must personally differentiate the inside part and put it at a small little bracket at the back. So can anyone tell me 6x minus 8, I differentiate, what will I get? Hopefully you guys tell me 6. My dear, because nothing here is 1. 1 times 6, 6. Power minus 1, no more x. Number differentiate is always 0. Because no, I repeat again why number differentiate is 0. Just in case you super fast forget. 0 times anything is 0. That's why it's 0. I get a 6 here. So 6 times 15, don't know, just press calculator, okay? 90. This one, still the same. No, I don't want to continue expand. I couldn't because there's a power 4 and I cannot simplify also. So yeah, that is the answer. Get a better idea of it? No, never mind. I still got a lot. Example, my dear, let's look at C. So I repeat again, don't tell me you times inside. You cannot because there's a power. And the power is 3, is not something you will expand also. So never mind, I couldn't go to the first method, but I can do the second method, which is differentiate with the bracket on. So we will times and minus 1, yeah? 3 times negative 2, isn't it negative 6? The bracket, then after that, we will power minus 1. 3 minus 1, isn't it 2? Will we stop here? Nope. The inside bracket, you will copy back whatever they previously write. And remember. After you times and minus 1 with this bracket, you must add a small little bracket for you guys to differentiate inside and put it at the back. Can you make a guess? 2 minus x differentiate, what will you guys get? 5, 4, 3, 2, 1. Not sure whether you're correct or not because usually people wrong here. Negative 1. Why negative 1? I repeat, the 2 differentiate will be 0 because no x differentiate is always 0, correct? Then this negative x, a lot of students will tell me 1, but it's actually negative 1 because you look. This x, nothing there is power 1. Nothing in front is 1. So we times, right? 1 times negative 1, negative 1. And power minus 1, no more x. That's why you still left a negative 1. Negative 1 and 1 make a huge difference with a negative or not, okay? Please don't make mistake. So negative 1 times negative 6, positive 6. Isn't it just like that? Again, I'm done. So this is C, next one, D. D, they give me this one. Okay, this one. Again, how do we do it? The moment you guys look at this, you guys will tell me, teacher, bring the x up. Yep, because that is always what we did, right? Based on all the previous example of today. Every single time you want to differentiate, please make sure the x is on top, not at the bottom. So now I realize the x at the bottom. What will I do? I'll bring it up. Then when I bring it up, some students very funny one. They will just tell me, teacher, bring the x up. How can you bring the x up? Guys, if you bring the x up, then you expect what? The 3 and the 4 stay at the bottom. You write that, don't you feel like a bit guilty? Like, doesn't make sense also. Guys, yeah, it doesn't make sense. Then what can I do for this one? I hope you guys understand that. Just now when I teach you guys the front part, here, okay? When we bring the x up, do you guys realize the x at the bottom? When we bring it up, they are still a times relation. So this one, they are a times relation. I bring it up, they are still a times relation, correct? Then how about this one? So this one, when I want to bring it up, correct? Okay, I cannot just bring the x up because this time they are not a times divide relation. This time I have a plus minus. So whenever you have a plus minus, you cannot just solely bring the x up. You cannot solely bring the x up because they have plus minus, they are all together. Since they are all together, instead of just bring the x up, you guys can bring the whole bracket up. Can you see it? So I repeat, if the x is alone, you guys can bring the x up. But if they start with a plus minus, you should bring the whole plus minus up, which is the whole bracket. So when you bring the whole bracket up, isn't it power? Just put a negative like how I taught you previously. So now you guys have this. Let's get started of differentiate dy dx. This time you know that you must use the bracket method to differentiate because quite obvious, you start with this bracket and you couldn't expand it. So let's start to do times and minus 1, yeah? Negative 4 times 5, isn't it negative 20? So next one, our power, we will minus 1. Negative 4 minus 1, isn't it negative 5? Will we stop here? No, the bracket part, isn't it? We will copy it back down. Remember, don't stop here. Add a small bracket for you to differentiate inside. Put it at the back. I think this one quite easy. 3x plus 4 differentiate will be very good. 3. This one nothing here, 1. 1 times 3, 3. Power minus 1, no more x. Number differentiate 0. Isn't it? You guys will get the 3 here. So 3 times negative 20, negative 60. The bracket still the same. So why stop here? No. Please have this good habit to make the power negative disappear. How do you guys do that? Isn't it? Bring it back down to make the power positive instead of negative. That. Can you see it? The step of doing it, I don't think you guys have any problem because eventually I just keep repeat the same thing. I hope you guys all okay. Next one, E. E a bit different. E a lot of students cannot do one. Like if your basic not strong, or maybe you didn't relate to that, okay? So E, they say y equals to 1 over 1 minus x. How do I do this one? I repeat again. Every time you want to differentiate, please make sure the x is on top, not the x at the bottom. What will you do? Some student will tell me, teacher, bring the x up. I already say, my dear, whenever you guys got plus minus, you cannot solely bring the x up because they are plus minus. How is it possible you bring up become times divide? Doesn't make sense, right? They should be like still the same. Okay, you cannot change the nature of the questions. So what will I do? Wherever they are plus minus, they are together. When they are together, you must bring the whole thing up. Then how do I bring the whole thing up? You look at the previous question. Previous question very easy because they already put a bracket. This one, they don't have bracket. Maybe it confuse you. It doesn't matter because if they don't put a bracket, actually I can add a bracket myself. If I simply put a bracket there, nothing power there, isn't it will be power 1 there. Then again, I think all we guys can do, I can bring the whole bracket up and put a negative 1. Isn't it things solved in that way? Saw it, my dear. So don't always expect they will put a bracket for you. Even they don't, you guys can add on yourself and put an invisible 1. And then you bring it up, the power still negative 1 and things solved, my dear. You bring the whole thing up. The moment you start differentiate, isn't it dy dx again? Let's again do it, times and minus 1. Negative 1 times 1, isn't it negative 1? Then the power, if we minus 1, isn't it become negative 2? What is inside the bracket? Isn't it still the same? Why stop here? No, you must purposely open a small bracket, differentiate inside, put it at the back. Give you one more chance. 1 minus x differentiate will be, yes, correct, negative 1. 1 differentiate is 0. This one, 1. This one, 1. 1 times negative 1, negative 1. Power minus 1, no more x. So you guys left negative 1 here, yeah? So negative, negative, positive. Again, please have the good habit to make the power negative disappear by bringing them back down. Ta-da! Done. Can last, okay? Even though I want to continue teach you because this basic of differentiate still got another part, but this video is already 40 minutes. Oh my God. My dear. So I think I want part 2 video, okay? So this one, F. How do we differentiate this? This one, first thing first, some student, just very minor of them, they will tell me, teacher, square root and square can set off. You don't tell me you can set off now because there is a plus minus. When there's a plus minus, you cannot cut like that. Then how do I do it? I want to differentiate it, but the square root is seriously very annoying, my dear, and I couldn't square root it. Then remember what you guys learned under indices? You guys learned before, third n can always become power 1 over n. So this basic tells us that square root, okay, this thing called square root, right? Square root, that means there are 2. 2, that means you will become power 1 over 2. Isn't it, if your basic quite strong, you guys will know that they can become power 1 over 2 and the way of doing it is still the same. Power 1 over 2 is not a bracket I can expand, so I will use the bracket method to differentiate again. So let's do it again, guys, times and minus 1. So this is the bracket. Nothing in front is a 1. So we times 1 over 2 times 1, isn't it 1 over 2? The bracket, isn't it always copy back? Then the power minus 1. 1 over 2 minus 1, don't panic. You can press calculator if you're scared. 1 over 2 minus 1, isn't it negative 1 over 2? Okay? So the way of doing it is still the same. Don't because they have negative 1 over 2 and then you feel like, oh, very lack of confidence, you feel like you're wrong. No, you are correct, okay? Then after that, differentiate inside, put it at the back. Can anyone tell me? 3x squared minus 2, if I differentiate it, what do I get? Not sure whether you're correct or not. 6x. Why 6x? Show you again. 2, 3, 6. Power minus 1, 1x, correct? And number differentiate is always 0. Isn't it? I left 6x here. Don't tell me, teacher, why got x? Because just now all my example, I give a very easy one. That's why all of them is just number. But it doesn't mean they must be a number. Okay to have an x there, okay? So don't panic about that. So how do I continue, my dear? So these two I join. 1 over 2 times 6, 3x. Again, please have the good habit to make the power negative disappear. By how? By bringing them back down. To make the power negative become positive. Will I stop here? No. Why? Because I love to write my answer in the most nicest form. And you guys all know, Square root can become power half. Then power half can become square root back. All the formula works two-way, my dear. So isn't it they can become like that? That hopefully after this video, you guys totally understand how to differentiate because you need this basic to survive through the whole thing. So in the next video, I will teach you guys product rule and quotient rule, okay? Which is the UV formula, okay? See you on the next one. Annyeong. Bye-bye.